Hi, this is Mr. West, and today we're doing a special request video for a Khan Academy exercise called Factors and Divisibility. This was requested by Shamsid Susan, so thank you so much for suggesting this particular exercise. This will be your tutorial video. Thank you, and you can always leave a comment to request your own. So for this particular Factors and Divisibility exercise, it goes over what are factors. So let's just jump into the first example. A teacher writes the following product on the board. So here we have a product written there, and it doesn't look like there's a product, but x plus 3 is being multiplied by x plus 4. And before we get into like who says what's a factor or it's not a factor or divisible, we need to boil down what is a factor. A factor is a number that divides another number with no remainder. So an example is 3 is a factor of 12. And you can write 12 divided by 3 equals 4. 4 doesn't have a remainder. I think the easier way to think of it is a number that you can multiply by another number. Okay, so for example, 4 times 3, and then 12 is like your answer, but 3 is your factor and also 4 is your factor. And there's multiple factors of 12, okay? So 12 can be divided by multiple numbers. Same thing with expressions like this. So we have x squared plus 7x plus 12. If we multiply these two factors together, we have this parenthesis here, that expression times that expression. Those two binomials multiplied together, it will give us that larger expression. So each one of these separately, and I'm going to highlight them in just a moment. So each one of these separately is considered a factor. So x plus 3 is a factor, and x plus 4 is a factor. So Hafsana says that x plus 3 is a factor of x squared plus 7x plus 12. He is correct, because we can divide or we can multiply x plus 3 times something to get that bigger expression. That's what I was trying to iterate earlier. I wasn't able to say it so nobly. So this is correct. We're going to give this a green check mark. Boom. And then Zheng Hao says that x plus 2 plus 7x plus 12 is divisible by x plus 3. Well, if you can multiply x plus 3 by something else to get that expression, then you can also divide it and have it not have a remainder. So both these individuals are correct. So we're going to put both, letter C. Okay, so key difference here, it might say that if someone said that x plus 3 is divisible by x squared plus 7x plus 12, that'd be wrong, because that's the wrong order. And hopefully that will come again so I can talk about that. But I've seen questions on this Khan Academy where it reverses it, and see if you can notice the difference. Which binomials are divisible by 9? So we're going here and we're trying to see which are factors, essentially. So we have 9x, we have negative 18 y squared. We want to see which of these we can divide by 9. Since it's just a number and then there's no letters, okay, there's no variables there, we can just look at the numerical coefficients and see if they are divisible by 9. And you can see that both of these numbers are divisible by 9. So 9 divided by 9 equals 1. Negative 18 divided by 9 equals negative 2. Both of these do not have remainders. Therefore, they're factors, okay? Both these are factors, or excuse me, 9 is a factor of both. That's how I want to say it. 9 is a factor for both these expressions. I need to choose A and B. You can double select there and then check that out. Okay, next question. Which monomials are factors of 11a cubed b to the 5th? This one's a little trickier. Okay, notice how both our options A and B do not have any coefficients. So we don't have to worry about the 11 there. Good thing, because it's prime. Okay, but we have to only concern ourselves with the letters. So we have a cubed. We want to know, can we multiply? Okay, so these are the factors. Okay, we want to know, can we divide this by these things and have it not have any remainders, okay? So can I divide, that's a terrible divide sign, 11a cubed b to the 5th by a cubed b squared? The one best way to determine if you are able to do that is to see if your factor has a higher power or a lower power. If it has a lower power for the both variables, then we're good, okay? A cubed, this is a cubed. Why is that okay? Because I can multiply a cubed times 1 to get a cubed. That's good, okay? So we can divide it. What about b squared? So this one's b to the 5th. Well, can I multiply b squared times something? Whoops, wrong utensil. B squared by something to get b to the 5th. And the answer is yes. I can multiply this by b to the third power. So b squared times b to the third equals b to the fifth. Therefore, this is a factor. We can choose at least a. What a check mark that was, by the way. Now, moving on to b, we have a to the fifth. Okay, so we have a to the fifth. Can we multiply this by something? Let me make these little boxes here. Can I multiply it by something to get a to the third? Or another way to say it, as we started with earlier, can I do a to the third divided by a to the fifth and have it not have a remainder? And the answer is no. Okay, there's nothing we can multiply here to have it equal a to the third that is not going to be a fraction. So this one is out. That one's out because our top choice was good, and we can choose that one. Okay, b was fine. B to the third was fine for that last example. Just want to talk about that real quick. So b to the third, we could have multiplied that by b squared to have it equal to b to the fifth. We would have been fine with the b, but not the a, and that's enough to disqualify it. Moving on to our last question. A teacher writes the following product on the board. So there's the product. So right away, if we have two things multiplied together, we know these are both factors of this bigger one. Kareem says k to the fourth minus, okay, the big expression is a factor of k squared minus 6. I'm going to come back to that. I want you to think about it. Justine says k squared minus 6 is divisible by k to the fourth, okay, that whole big expression. Both of these individuals are wrong, okay? Why? Because these ones, okay, these smaller ones are a factor of the larger one, not the other way around, not the big one is a factor of the smaller one. Okay, we can't do k squared minus 6 divided by all that and have it not have a remainder. That's no good. Okay, so this one is out. Kareem is wrong. If we were to switch these, okay, saying k squared minus 6 is a factor, that would be fine, but not the other way around. The big one is not a factor of the other one. The other smaller one is a factor. Okay, smaller ones are the factors, and the bigger ones are the products. So Justine says that k squared minus 6 is divisible by k to the fourth minus that. That's also wrong, okay? The product, okay, the bigger one is divisible by the smaller one. So if this were flipped, it would be fine, but it's not. This is what I was alluding to at the first problem, and I'm glad we were able to kind of wrap it up with this last one. Let's check it out. Neither of those kids is correct, and we're done. That's 100%. Hopefully you enjoyed this video. Thanks for watching. Again, you can request your own video right here on any of these videos. Just leave a comment. And I look forward to seeing you next time right here on Wes Explains Best.